simplify the limit as x approaches 0 of absolute value of 2x plus 7 minus absolute value of 2x minus 7 all over x. Now, we come across a limit most of the time. If you can try to evaluate it, just plug in and evaluate it. And in this case, we'll say, okay, absolute value of 2 times 0 plus 7, well, that's 7, minus absolute value of 2 times 0 minus 7, so that's absolute value of minus 7, that's also 7. And plugging in x equals 0 on the bottom, you get 0. So we'll get 7 minus 7, 0 over 0. So that's not a does not exist. That's not, it has to be 1, it has to be 0. What this means, this is an indeterminate form, and this just means you probably have to do more work. There probably is a limit, but this expression is not helpful. It's not conducive to getting an answer. So what should we do? Well, absolute value is a piecewise defined function. Depending on what you put in, you get different things out. Okay? So I have a here. A is standing in for an expression like 2x plus 7, or x cubed plus 3x squared minus 2 to the x, something like that. Okay? But if your expression has a value that's bigger than or equal to 0, absolute value doesn't change it. Remember, absolute value doesn't change positive things. It only changes negative things. But if you put in an expression that is less than 0, not a number, by the way, an expression, and expressions can change based on the x's that you're working with, but if you put in an expression that is less than 0, then you make it positive by putting an extra minus sign out front, because minus of something that you've already established is negative is positive. So absolute value spits out a positive thing in that case. So let's look at the two absolute value expressions here. Because I know it's tempting to do things like, hey, this 2x and this 2x cancel out. Arithmetic doesn't play nice with absolute value. So if we're going to do any sort of factoring or rearranging or rewriting, we have to get rid of the absolute value signs, and that means replacing them with some sort of sub-formula or sub-function. So let's look at the two absolute values. Okay, so 2x plus 7 is my a, it's my expression. So we get it out unchanged if we're looking at something that's greater than or equal to 0, but we'll stick a minus sign in front of it if whatever, depending on the x value, if 2x plus 7 is less than 0. Okay. Similarly, 2x minus 7 in absolute value, well, you'll get 2x minus 7 out if 2x minus 7 is already itself positive, and that'll change. Different x values will make positive values or 0 or negative values. And you'll get minus 2x minus 7 if 2x minus 7 is negative. Okay, now let's ask ourselves, we're not talking about the whole functions or anything like that, so we're going to replace everything, but if x is getting closer and closer to 0, is 2x plus 7 going to be positive or is it going to be negative? Well, we can do a quick little check. We can say, okay, 2 times 0 plus 7 is 7. That's decidedly positive. So even if we put in something that was close to 0, you're still going to get something that's positive. So near 0, this is the way we think through limits, right? This is not rigorous or exact or precise calculation. This is me thinking through and understanding limits. Near 0, 2x plus 7 is greater than or equal to 0. So near 0, when x is near 0, I can replace the absolute value with this formula here. We can do the same sort of thing. Let's grab our orange, I guess. Near 0, 2 times 0 minus 7 is going to be minus 7, which is negative. And again, doesn't matter which side of 0 you're on. If you pick something that's close to 0 and plug it in, you will get something that is less than 0. It's going to be close to negative 7. So it's decidedly on the negative side. So as far as we're concerned, when doing this limit, when the x inputs are near 0, absolute value of 2x minus 7 is no different than minus 2x minus 7, which we can distribute the minus sign, by the way, and call it 7 minus 2x. So from there, we can rewrite our limit. Just replace the absolute values with these functions. Now, of course, if x was approaching a different value, we might have different results, and we might have to replace with different subfunctions. That can happen. But near 0, absolute value of 2x plus 7 is the same as 2x plus 7. And near 0, absolute value of minus 2x plus 7 is basically the same as 7 minus 2x. Well, not basically, it's exactly the same. Okay? So now we can come along and we can resolve this a little bit more. Okay? So we can come along and we can say, oh, okay, well, 7 minus 7, those guys will cancel out. 2x minus negative 2x, that's 2x plus 2x, that's going to be 4x. So we'll get a 4x when we simplify on top. We couldn't simplify with the absolute values. They don't let you subtract or add easily. But now that they're gone, thanks to our little work, our little understanding of a piecewise function, now we've got 4x over x. Well, the x's can divide out. We've got limit of 4. Limit of a constant, well, that's just 4, and that's going to be our answer.